Hey, 20-1s. What we're going to do in this lesson is we're going to keep exploring absolute values. And what we'll do is we'll look at what the absolute value function a little more. And the main focus here in this will be about the graphs of these absolute values. So remember from the last lesson, an absolute value means we're finding the distance from zero. Let's look at the graph of this. Okay, so our base graph is y is equal to the absolute value of x. So let's go grab our graphing calculator and let's put that in. Okay, I've got mine on green. Why not? I like it. So if we want the absolute value, what we do is we go over to num, abs, x, and hit graph. There it is, pretty green. Okay, I need you to know all the basics of this graph. So let's draw this thing. So what we just had, just like that. And we had this pretty looking, look, I'll even make it bright neon green, like that. Okay, it's a really basic graph if you're thinking about it. There's not a heck of a lot to it. So our domain, well, it's infinite. It goes to negative infinity and to positive infinity. Never stops going to the left, never stops going to the right. The range, well, it starts right at the origin there. So it's greater than or equal to 0. And the x-intercept and the y-intercept is at the origin. It's at 0, 0. So there's our most basic graph. Okay, what we're going to start doing here is we're going to do a couple things. We want to figure out how to draw this thing by hand, and we want to relate it to linear and quadratic functions. So let's do that now. How does the graph of the absolute value of x relate to just the graph of x? Okay, let's just do this one in our calculator so you can figure it out. It's actually not so bad. So I've already got the absolute value of x drawn in. So what I'm going to do is I'm going to graph x, just like that. And I'm going to say, okay, what happens? So the blue graph is the graph of x. Well, remember back to last lesson, the absolute value of x is taking anything that's negative and making it positive, because it's talking about how far away am I from 0. What that's doing here is, do you notice this part where I'm drawing over in blue stayed the same? Because all the y values were already positive. But on the other side here, I'll maybe change to red. Down here, when we were under the x-axis, all those y values were negative. So what the absolute value function did on this portion that was negative is when we took the absolute value, it made all the corresponding y values positive. So like say this point right here, it looks like it's at like say -7. Well, it then made the y value +7. This point here looks like it's at, I don't know, -2. It made the y value +2. So notice the x values aren't changing, just the y values are changing. So when we take the absolute value of a graph, what we're doing is we're making our y values positive. So we're only taking the absolute value of the y values. Or you could also think of that as the output, or the dependent, or the responding, whichever way you want to think of that. That's what it's doing. Okay, what is this going to do when I give you a more complicated function, like x plus 4? Okay, so first thing we're going to do without a calculator is we're going to draw this guy. So going back to 10C, I need you to remember how to draw this thing. So what this says, it says the y-intercept is at 4. So that's where I'm going to start. Then what I'm going to want to find is the x-intercept. So my slope is positive. So to reverse it, I'm going to go down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Okay, my x-intercept's at -4. And this thing just keeps going, right? And so if I was on a paper assignment, I would whip out a ruler, but there it is. There's the graph of y is equal to x plus 4. So how do I draw the graph in lovely hot pink of the absolute value of x plus 4? Well, I'm going to think of this as breaking this graph up into the positive portion and the negative portion. So I'm going to start at the x-intercept. That's not going to change, 0, 0. Anything that's larger than -4 had a y value that was positive. So those aren't going to change. But anything that was less than -4, like this point right here, at -5, -1, when I take the absolute value of it, it makes the y value positive. And we just keep making them positive. And pull out my ruler, and I'm going to get a sharp V. There it is. That's how you draw that. So what we did was we found the x-intercept. First, that's going to be your most important point. The y-intercept's important too, but the x-intercept's most important. And then anything that's positive stays positive, and anything that's negative has a y value that's negative and output that's negative, we're going to make that positive. Okay. What we're going to do now is we're going to write this as a piecewise function. How do we do that? So we're going to take the absolute value of x plus 4. Well, there are two parts. There's the part that was already positive. It had output y values that were positive. And there was the part that was negative, like that. And then I say to myself, but when? Like, because it's not always positive or always negative. So I'm going to say if, and for the first one, okay, where was I positive or even equal to 0? Well, starting at the x-intercept at -4. So I'm going to say if x is greater than or equal to -4. Where was I negative? When I was less than -4. Just like that. Okay, so that's it. That's called a piecewise function. You'll play around a lot with those in calculus, maybe at the end of next year. All right, there we go. Let's try another one here. Let's look at this quadratic. Y is equal to x squared plus 4 minus 6. You know what I'm going to do on the fly? I'm going to change that -6 to a -5, okay? That'll just make it a lot easier, trust me. Just notice I made that error. Okay, let's pretend we don't have our graphing calculator. So the first thing I always want to do is I want to find the x-intercepts and the y-intercepts for that matter. Okay, y-intercept's easy. It's your constant term. So my y-intercept is at 0, -5. Easy peasy. Okay, x-intercept, well, x-intercept, I know I'm going to let y equal 0. So set that equal to 0. I'm going to factor x plus 5, x minus 1. And so I know now my x-intercepts are at -5, 0, and 1, 0. Perfect. Okay. Now the other thing I want to find is my vertex, because I mean this is a quadratic. So let's find that vertex. So to find that vertex, what we're going to do, remember, is we're going to complete the square. And so we take our middle term, divide it by 2, and square it, balance it by subtracting 4. And so we put this thing in vertex form, which is x plus 2 squared minus 9. So our vertex is at -2, -9. Okay, let's go graph this thing. What do we get? Okay, so we've got an x-intercept at -5. Where was the other one? +1 or -1? +1. Okay, and our vertex was at -2, -9, so way down here. And our y-intercept was there. So here is the graph of our original quadratic. There it is, nice and smooth. There it is. So what does the graph of the absolute value of that look like? Here's what I'm going to say. Where was the original graph? Positive. Where did it have an output that was greater than or equal to 0? Well, I look at my x-intercepts like that. And right there it was positive. Right there it was positive like that. And then what I'm going to say is let's look at now what about where we were negative? Well, the y-intercept was at -5. So the absolute value of that will now be +5. The vertex was at -2, -9. So the new vertex will be at -2, +9. And what we get is we get this W looking shape, just like that. That right there is the absolute value of x squared plus 4x minus 5. Okay, so again, we break it down into the where was I positive, where was I negative. Okay, what's our domain and range of our new absolute value? Well, domain is infinite. The range is greater than 0. Okay, and as a piecewise function. Okay, here's the part that sometimes is the trickiest part as you're getting used to writing this. So the absolute value of x squared plus 4x minus 5, I'm going to think of it as broken up again into two parts. The positive part, like this, the negative part, like this. And then I go back to my graph, the original graph, and I say, okay, if when? Well, where was I positive? I was originally positive when I was less than or equal to -5 or greater than or equal to 1. So when I was less than or equal to -5 or when I was greater than or equal to 1 is where I was positive, or maybe again, I should say non-negative is the correct term because I'm including when the value is 0. Where was I negative? Well, when I was under the x-axis, so between -5 and 1. So between -5 and 1. And see how I'm only including the equals bar on one of them, not on both. Now, it's kind of arbitrary where you put it. I could really put it on either the positive or the negative portion, but it seems to be a standard that we put it on the non-negative portion. Okay, there it is, friends. And again, you can graph that in your calculator. So really quickly, let's do that. So let's grab our calculator. Okay, clear all this garbage out. All the way down here at x is equal to 5. Okay, so if we graph our original parabola like that, and then I can take the absolute value of that. So again, I go, oh, not mode, I go math, sorry, over to number, and then I can, oops, I'm in the wrong section altogether. Try that again, math, over to num, and then I can graph what was in y1, and here we go, ready? And my memory's broken. Oh, because I'm stupid. Try that again is the answer to that question. Geez, I do need a coffee. I'm trying to graph what I've got in. I think I had it in Y5. Sure I did. Okay, try that again, guys. And there it is. Look at that. So the green was the original parabola, and the absolute value was kind of the W looking shape. So there it is, friends. That's how you graph these things. You find the x-intercepts. You say, where am I above or below the x-axis? That tells me where my graph was positive or negative, and you just work your way from there.